Let's create a simple map of all the architecture styles in this video. Let's first recap what we have learned so far. We have learned what is software architecture style, and we also learned that centralized versus distributed architecture is all about where control and responsibilities live. Now, why do we need this map? Without this map, if we simply list all the architecture styles one by one, they would feel random. Instead, if we organize all the architectures in this map, then we can use this like a vantage point. From here, we'll be able to see how different architecture styles will solve different problems and how they compare with each other. But I just want to be very clear here, it doesn't explain everything. It only explains the core idea of each of the styles. So just by looking at this map, you can't answer all the questions, but you'll be able to grasp the core idea of each of these architecture style. Now, how do we create this map? How do we organize architectures and put them in this map? Well, for that, we are going to ask two questions. And every architecture style can answer these two questions. And depending on the answer, we decide where to put this in the map. Okay, what is the question 1? The first question is, how many architectural deployable units are there in the system? So this is the first question. Now, this is not talking about how many servers you have, and it's not talking about how many binaries are there, and it's not even talking about how many deployable units you have from the operational or release management perspective. So this is very important. So we're not talking about deployable units from the operational or release management perspective. We are talking about architectural deployable unit. Now, what is this architectural deployable unit? Architectural deployable unit means it is part of the system that can be changed to deliver meaningful business behavior without requiring other parts to be released at the same time. Okay, so architectural deployable unit doesn't mean operational or release management deployable units. In order to deliver a meaningful business change, if we need to make changes to multiple deployable components from the operational perspective all the time, then all of those components will be treated as one deployable unit from the architectural point of view. I know this architectural deployable unit is still very abstract, and let's look at these in detail with some examples. First, let's start with monolith architecture. In monolith architecture, we normally have just one deployable unit. It doesn't mean we just have one component. It just means that we deploy them together. In this example, we have two components, which is application and the database. But this is still considered as one architectural deployable unit because whenever we want to make any meaningful business change, we probably need to change both application and the database. So this is why this is considered as one architectural deployable unit, even though it has two release components. So we need to release the application separately and we need to release the database separately from the release management or operational perspective. But from the architectural perspective, this is just one component, one deployable component, because whenever we want to make changes, we need to make changes to both of these, and both of these need to be released at the same time. So like I said, it will be released, versioned and rolled back as one unit in order to deliver any meaningful business change. Now let's look at the microservices architecture. In microservices architecture, we may have multiple independently deployable services, and in order to make meaningful business change, we may need to change one of these. We don't need to change all of these, and we don't need to deploy all of these or some of these. We could just make changes in one of them and deploy that without releasing the other services. So in theory, each of these services are deployed independently. We'll develop them and deploy them independently. We don't need to have release coordinated with other services. We can simply develop one of the service and deploy that service. So for example, assume that this microservices architecture is for e-commerce site. So we have this component is responsible for product listing, and this component is responsible for payment, and this component is responsible for communication like sending emails and SMS. Now, if you want to change how email or SMS is sent, then we just need to change and release this component. We don't need to touch the other components because they are not required to be changed and released for this particular meaningful business change. But in practice, we may have dependency. So in theory, each of these components are independently deployable. But in practice, we may have dependency. We may need to release these two components together all the time. Okay, it could happen. If that happens, what it means is that we have not realized the architecture yet. So if we have implemented this correctly, we should be able to deploy this and this independently. But because we need to deploy these two together all the time, it just means that we haven't reached that end goal. Okay. But it doesn't invalidate the architecture. The architecture is still sound, but we are working towards making these two components independent. Now, I just want to make it really clear that sometimes we may need to make changes to multiple components and we may need to coordinate the release among them. This is because if you are developing a really large feature and that feature needs changes in multiple components, then we will make changes to those components. Then we may need to deploy them in a particular sequence in order to make sure system functions as expected. So for example, if you are adding a new payment method, the payment service need to be changed for that. And once the payment service is changed, we also need to make changes in the product listing to display that particular new payment method that we have added. So when we are developing this feature, we may need to change these two components at the same time and we may need to release them at the same time. This is because we have new payment processing mechanism in the payment service and this particular service, which is the product listing service, depends on it. And if we don't sequence it properly, then we may have problem in the system. And in order to avoid that, when we are developing and deploying this feature, we may need to do the coordination and we may need to release the components at the same time. But this is just an exception. Once this particular feature is developed, each of these services go back to being independent. We can still change each of these components independently to deliver meaningful business change. We don't have any real release dependency after this particular feature is developed. We may have similar feature in the future, but these kind of situations are just exception rather than normal state. Okay. Now, I also want to make it really clear what type of dependencies we are talking about. So there are two types of dependencies. The first one is called runtime dependency and the second one is called release time dependency. Runtime dependency is very common. Even though we have multiple services, they are independently deployable. They are not going to run in silo. At runtime, they'll be talking to each other. They'll be coordinating with each other, which is expected. We don't want our services to be in silo. We want them to work together to achieve what we want them to do. So this is a normality. This is expected. Okay, so we're not trying to avoid this runtime dependency. What we are trying to avoid is we are trying to avoid the release time dependency. If this component has to be always released with this component, then that is release time dependency, and that is the type of dependency we are trying to avoid with this type of distributed architecture. Okay, so just to be clear, independence doesn't mean being useful in isolation. It means not having to coordinate releases. Okay, so if we don't have to coordinate releases of multiple components, then we have achieved the independence. Okay, now that is out of the way, let's recap what is our question 1 again. So our question 1 is how many architectural deployable units are there in the system? So that is our question 1. Now what is our second question? Second question is how clearly are responsibilities separated? Okay, so this is our second question. Now imagine a system which looks like this. We have different components and there are overlaps in the component and anything can talk to anything and we don't have clearly defined boundaries. So this is an example of a system where we don't have clearly defined responsibilities, right? Responsibilities are not separated or defined. On the other hand, if we have a system like this where the boundaries are clearly defined and the interactions are really clear, and we also have a constraint to say that this particular component cannot talk to this component directly. So this is an example of a system where responsibilities are clearly defined and separated. Okay. Now the components that we see here doesn't have to be independent deployable unit. Okay, so it doesn't have to be independent deployable unit. All of these can be still part of one deployable unit. Within this one deployable unit also, we can have clearly defined responsibilities and communications and constraints. This is still considered as good example of clearly defined responsibility. Okay, I just want to reiterate here that defining responsibility doesn't mean that we need to make them as independent deployable unit. It can still be part of one deployable unit, but within that we can have clearly defined responsibilities for each of the subcomponents. Now that is out of the way, let's understand how we are going to create this map. To create this map, on one axis we are going to have number of deployable units, and on the other axis we are going to have how well the responsibilities are separated. So these are the two axes, and this is what going to give us the map that we were talking about. Okay, here on the lower left corner we have unstructured monolith. So we have just one deployable unit, hence it is monolith, and we don't have clearly defined structure within that monolith. So this is called unstructured monolith, and this is not really good. Most applications starts this way, but this is not a good place to start with. Then in the top left corner we have structured or modular monolith. Okay, so this is good. We still have one deployable unit, so this is called monolith, but we have clearly defined structure within that monolith application, and because of that this is still a good architecture. Okay, so we have monolith application, and within that monolith application we have clearly defined structure with the clearly defined responsibility that sits in the top left corner. And then on the bottom right corner we have poorly designed a distributed system. So distributed because we have many deployable units, but it is poorly designed. We don't have clearly defined responsibility, we don't have clearly defined interactions and constraints. So because of that, even though this is a distributed system, this is poorly designed and it sits at the bottom right corner. And then in the top right corner, we have well-designed microservices or event-driven system. So event-driven system can also be seen as microservices system, because event-driven is just the communication mechanism, right? So microservices architecture can be REST-based or it can also be event-driven. So both of them sits in the top right corner here. And it sits here only because this is well designed. So the microservice architecture is well defined. We have clearly defined responsibility for each of the services. We have clearly defined constraints. So because of that, it sits in the top right corner. Now, in practice, we may have many systems that sits somewhere between these four. Okay, and this is also what you find in practice. Now, architecture style is all about just a position on this map. So your system may sit somewhere in this map. So that is what architecture style is all about. I just want to make it really clear that distributed system is not better than centralized system in general. If we have poorly designed and structured our system, regardless of whether it is centralized or distributed, it is a bad system. So we can have distributed system and that could be designed badly, then it is still a bad system. So going forward, we are going to look at various different architecture styles that are common in practice, and we will start from simple ones and move on to complex ones. So that is what we are going to see in the future videos. That is all I wanted to talk about in this video. I hope this is useful. Thank you.